Hello there. In this lesson we're going to learn some more about functions. We're going to look at some important keywords and we're going to practice what we learnt in the previous video, our mapping diagrams. There are certain terms, keywords, that are associated with functions, and they're quite important because they come up quite regularly in exams. Some of them are quite tricky to learn as well because they have different meanings for different aspects of mathematics or in different everyday language. Some of them we've already looked at. For example, an input. We know that an input is an object or an element that is put into the function, and the function can simply be a calculation described by its rule. We look at our first new term. It's called the domain. Now, the domain is the set of all of the inputs that we are going to put into a particular function. So rather than just looking at one particular input, we might be interested in all of the inputs that we're going to use, and they together are the set that's called the domain. You might have heard this word before, for example, the domain name for a website. So it's important that we know it means something very different when we're talking about functions. Another term we've already looked at is our outputs. And if you recall, an output is the object or element, so typically the number, that comes out of the function after the input has been undergone a transformation during the rule of the function. So they are our results. And if we're interested in the set of our entire results, then we call that the range. So the range is the set of all of the actual outputs from a function. Now, this definition can cause some trouble because there is another range in mathematics, and that refers to when we look at statistics. In statistics, the range of values is the difference between the smallest and the largest. So it's very important that we read the question to know which range we're being asked about. If the question is a function question, then the range simply means all of the outputs that we got from this particular function. We have one last new keyword, and that is called the codomain. So this is similar to domain, but we have this co in front of it. It's very important then that we don't get them mixed up, because the codomain is nothing to do with the inputs at all. The codomain is the set of all possible outputs that we could have had, whereas the range are the set of actual outputs. For example, before we conduct a function, before we put the inputs in, we might state that a codomain is all the natural numbers. And if you remember the set of natural numbers, notated with the capital letter N, that is all the whole positive numbers starting from 1. 1, 2, 3, 4, 5, going all the way up to infinity. So the codomain is all of the natural numbers. But once we have actually conducted our function, we might only have 5 outputs to match the 5 inputs that we put into our function. So the 5 results are the range, the actual outputs, whereas the codomain was the set of natural numbers. So the codomain will always be either the same size as the range, the same amount of outputs, or it will be larger. Let's have a look at a question example. Imagine a secondary school like our own, in which the second year classes are called 2-1, 2-2, 2-3 and 2-4. Each class is going on a class trip. they can choose from the following options. They can either go to the cinema, the zoo, go-karting, paintballing, or bowling. 2-1 choose the cinema, 2-2 go-karting, 2-3 choose go-karting as well, and 2-4 choose paintballing. These choices can be represented by a function, and we can do that through the use of a mapping diagram. Let's have a look. So we know that our initial inputs are our classes 2-1, 2-2, 2-3, and a 4. Our outputs then will appear in our second circle, and if you recall, there were 5 choices. We can use our arrows to show which output the inputs mapped to. And as you can see, not all of the destinations or trip choices were made. So that means that whilst we have 1, 2, 3 outputs, so the range is cinema, go-karting, and paintballing, but the codomain was all the possible outputs, and that was all 5 trip choices. And we know that this is a function because we are allowed to go from many to 1. These 2 class groups chose the same trip, and that is okay. It's a requirement. It's considered suitable for a function. We know that 1 input can't go to 2 outputs, but 2 inputs can have the same output. So go-karting is an example of an output. 2-1 is an example of an input. Let's have a look at the domain then. You might be asked to state the domain and the range, or even the codomain for a particular function. So this is how you could write it. The domain is the set which we know we notate with curly brackets, and we list all of the inputs. So in this case, it's all of the 4 classes. There we can see that the domain is the set of all of our inputs. Now the range then is the set of all of our actual outputs, the ones that were chosen: cinema, go-karting, and paintballing. It's still a set, so we must put them all inside our curly brackets, and we must separate them with commas. And then finally, we know that the codomain was the set of all of the possible outputs, and that's all 5 of the trips, again inside a pair of curly brackets. Let's go over some of what we learned in the last video about mapping diagrams. Remember how we said it's very important that we know whether to identify if a function exists or not. Well, each of the following mapping diagrams represents a relation. Let's identify the ones that also represent a function. Let's look at A. Is it a function? Each input maps to a unique output. So yes, it is. B. We have 2 inputs mapping to the same output. This is a case of many to 1. Can you remember whether that's acceptable for a function? Yes. Yes, it is. 2 different numbers can start and then go into a function and result in the same answer. C. We have 1 input that goes into a function and gives 2 different outputs. Is that a function? No, it's not. We can have many going to 1, but we can't have 1 going to many. D. We've got 2 inputs going to this one, and the bottom 2 going to this output. It's many to 1 twice. And yes, That's okay. Many to one is okay. Let's look at E. Well, there's actually two problems with E. This is not a function. Not only do we have one input resulting in two different outputs, which is not acceptable, but we also don't have an output for this one input at the top. Every input must have a unique output. And then lastly, this is not a function. Whilst the 2 at the bottom, many going to 1 is okay, but this one input going to many outputs is not okay. Let's look at a more difficult question. This time we haven't got the mapping diagrams drawn for us, so we have to decide whether they're functions based on the couples or ordered pairs. If you recall in the last video, we learnt that the couples or ordered pairs are the set of all inputs at the start of a bracket, separated with a comma from their outputs at the end of the bracket. So for A, we have the input 1 appearing twice, the input 3 and the input 2. It seems like our single input number 1 is resulting in two different outputs. It's a one to many. Well, that's not possible for a function. So the relation A is not a function. We're asked to give a reason for your answer, and using the official keyword definition would be suitable, that every input has to have a unique output. And this input is not having a unique output. It has 2, 4 and 5. B, we don't have any duplicate inputs and we don't have any duplicate outputs either. So that's much easier to identify that it is a function. Every input has a unique output. C, we have the inputs 1, 2, 3 and 5. You'll notice that both the input 2 and 3 have the same output number 4. So we have many inputs going to one output, many to 1. Is this a function? Yes, it is. It's okay to have many to 1, but it's not okay to have 1 going to many. And lastly, for D, similar to A, we have the same input coming out with different outputs, 1 to many, and we can't have that. D is not a function. Let's test our knowledge on our new terms. It's very typical in an exam that you would be asked to list the range, to list the domain, the codomain, etc. The domain is the set of all inputs. So on this function, which is called G, as you can see from the little letter above the arrows showing the mapping, the inputs are all the elements in the left oval. So therefore the domain is the set 0, 1 and 4. And we know that we put sets in a curly bracket and we separate the elements with a comma. The range is the set of actual outputs that have occurred as a result of those inputs. So 0 has the output 1, 1 has the output 2, and 4 has 17. So those 3 are the only actual outputs. Nothing is mapped to 20, so we cannot include 20 in our range. The range is therefore the set 1, 2, and 17. And lastly, the codomain is all the possible outcomes that we could have had. Well, that consists of the range, the actual, plus any others that we didn't include in the range. And that means 1, 2, and 17 plus 20. Let's look at a more difficult question. Write down the domain, codomain, and range for each of the following relations and identify which are functions. Questions like this that have more than one topic that they're asking you to do might require you to underline the question to make sure that you don't forget to answer any additional parts. Let's look at A. The domain is all of the inputs, 0, 1, 2, 3. The range is the actual outputs, 0, 3, 6, and 9. And the codomain will be all of these elements in our right oval, including the range and also the number 4. Is this a function? Yes. Each input maps to a unique output. B. The domain, the codomain. The range is just the 3 outputs at the end of our arrows, 4, 7, and 11. Is this a function? We've got many to 1. That's okay. Yes, it's a function. C. Domain, all 3 inputs, -3, 3, and 4. Range, the actual outputs, 13 and 20. Codomain, all 4 of these elements, 5, 8, 13, and 20. Is this a function? We have many going to 1. Yes, it is. Many to 1 is suitable. And lastly, for D, we have domain, all 4 elements in the left, all 4 inputs. The codomain is all of the outputs that were possible, those that are actual and any that weren't actual. And the range are just the outputs that have actually occurred. So 5, 7, and 8. Is this a function though? Well, we have number 6, the element 6, 1 input, resulting in 2 outputs, 1 to many. That's not possible for a function. It is not a function. Just before you go, what did the maths book say to the other book? I have enough problems to solve of my own. Thanks for listening, and I'll see you in the next video.